not forgetting the dangerous demo I did quite long ago. Must have been quite impressive. I'm Wolfgang. I work at Frequentis Corporate Research. So as part of Frequentis AG, an Austrian company providing control room solutions. And my focus at Frequentis is IP real-time communications and standardization. And that's actually the things that brought me to SIP and Kamailio. And today I'll talk about Kamailio for next generation emergency services. As Daniel already mentioned, there's the LOST module. I've developed as part of a private initiative that we started to implement a standards-based chat solution for Austrian emergency services, which is called DEC 112. I'll have some information in the slides anyway. So I'll turn off my camera and switch to the presentation.
Looking forward to it.
Okay, can you see the slide deck?
Yes, looks fine.
Okay. Yep, Kamailio for NG emergency services. So there's quite something to talk about because there was a lot of changes recently, especially when preparing for a quite interesting interoperability event. It's a ETSI Plugtests event. Actually, it was a joint event together with the US. This caused a lot of changes, a lot of nice features that are required in order to interwork with other elements in an emergency services IP network. I will talk a little bit about basics, just to give you an idea of what the LOST module does in the context of emergency calling. Then some introduction about the main new features that are available now with the module. A little bit about interoperability testing. As I mentioned before, we had a real cool event earlier this year. And then also talk a little bit about projects. So there's actually a system in operation in Austria, and then closing with a summary. So for the basics, just to understand the role of the LOST module and Kamailio in the context of emergency calling or next generation emergency calling. So you'll see that there's a lot of changes right now going on in the originating network side. So we have mobile network operators that switch to voice over LTE, which is purely IP-based, and there are other technologies like the classical VoIP stuff and next generation eCall in Europe, for instance, which also switches to SIP-based emergency calling solutions. And still, there's some legacy world. What's needed is actually a new idea of mapping and routing. So looking for new capabilities for mapping and routing that serve all those new originating networks. So in the traditional number-based emergency call routing, which we had in the past, which is still in use in countries, we just use a number. And if we originate from an IP network or from a voice over LTE network, you can't use this kind of traditional routing anymore. So you need some new solutions for the mapping process and for the routing. And basically, if we look into NG emergency call services, they support this location-based routing with a new idea using the location coming directly from the device and polygons for the mapping. So there's the famous service URN, the location, which is the input to the mapping service, and the output would then be a URI that points to the next hop, which typically is a PSAP or another routing entity. And the decision when starting with the standardization, I guess already 15 years ago, was to use the session initiation protocol for all that kind of thing, and also integrate other services where we have a lot of, let's say, HTTP-based interfaces to connect to. And the LOST module is the core feature or function in that context that enhances the Kamailio proxy to also interface with a mapping service or with a location information service. So let's say the environment we have to interconnect or we have to deal with are usually the ECRF or emergency call routing function. That's the mapping functionality in the NG context. And the interface to that, or the protocol being used, is called LOST protocol. It's location to service translation protocol, which returns the next hop URI. So as I said before, input is location and the URN, and what you get back is the next hop URI. In some cases, the zip routing entity in the ESI and the ESRP would also have to interface with the location information service, especially if a client cannot provide location information, then it would just use the identity that comes along with the session setup and query the held. So basically we have two interfaces. One is called HTTP-enabled location delivery, held. The other one is called LOST, and they are standardized in the context of NG112 and 911. In addition to that, there are some, let's say, domain-specific extensions to zip. Not saying that something's being reinvented. It's already there. It's just the use of call info headers, the use of history info headers, and things like that. And what's being described in the standard is, okay, what's the content for call info header? There's a certain namespace defined by NENA, for instance, to set the call incident ID for the emergency calling and things like that. In addition, as usual in other domains, we use DNS and also NAPTR. So that's quite important, for instance, to get the URL to a LIS. So dynamically configuring the LIS URL using NAPTR. And on the other side, also LOST, if it gets to a redirect, would also provide or would also require NAPTR support. So that's also part of the LOST module. So basically, LOST module can be considered as the standards-based feel-good package. So if you just set it up, provide the URLs to the ECRF and to the LIS, it should work out of the box. So the only thing you would have to take care of is the URL that is being returned from the module and put it on the right place in the routing logic. Yeah, just summarizing that base functions. So actually, LOST module builds upon the HTTP client API functions, and we had quite good experience in the interoperability testing earlier this year with the DLS capabilities coming with HTTP client, or in fact with Kamailio. So it's not just TLS; it was also MTLS. So we had the mutual authentication capabilities being tested. We also had to load certificates that we got from BSAP credentialing agency from the US for testing purposes. So actually we went through a real credentialing process for this Plugtest, and it was really good to see how easy it is to integrate certificates and to use TLS with Kamailio. Yeah, basically the module itself takes all the information from the zip header and also, if necessary, of course, from the body if you get the location by value. And typically it's the service URN in the request line. It's the identity coming with the PAI header or with the from header. Location information can be a reference or can be a value itself. Returned attributes next hop URI, location, value, or reference. So the idea behind that returning location reference is also to use it or to be able to forward it to the next hop. So if you get the reference from the list, we could easily integrate it in the signaling flow and just provide the reference to the next hop, which doesn't have to query again a list server and simply dereferences with the URL that's already provided. So I think I mentioned that already before. The basic configuration would be for NG 112.9.1 capabilities, only containing the URLs to the ECRF and to the lists, and of course also, if necessary, certificates, and this can be simply managed with the HTTP client parameters. A few words about the features. So as mentioned before, we have to interface in that context with a location information service, which supports or implements the HTTP-enabled location delivery protocol. So actually, a location information service supplies location in the form of a beta flow, which is called location by value, or a location URI, which we call a location by reference. So in some scenarios, a calling device may not know its location or may not be able to provide a reference, or just provides a reference. So in any case, there's a need at the ESRP or the Kamailio with the lost module to support held requests. And the held protocol actually has two flavors. If you get a reference, you could just simply send a GET to dereference, but it's actually recommended to use a post and to provide additional attributes with the post request to get to dereference also location information. If the lost module does the held request, it simply takes information from the zip header or a function attribute. So what's also possible is to just set a specific identity and say, okay, I would like to query with that identity. So that is, for instance, if you need to translate from one identity to the other identity and do this in the routing logic. Quite new feature is list discovery using a NENA resolution. So what happens here is that we take simply the domain name as input and produce a URI that identifies or get the result via NENA to have this URI that identifies the list. And what the lost module does is just creating the right request via NENA using the proper service tags and application protocol tags. And the example shown here is simply that you have, for instance, a service provider, a VoIP service provider. Let's call it the yellow VoIP service provider that has a list in operation, but that list is not known by the ESRP, but there's some peering with an ESI net. And what can we do then is, okay, take the domain from the from or the PIE header and do an NENA request and find out if we get a list URI that we can use and query afterwards. So usually list is configured, and perhaps that's kind of a ESI net setup where we know your lists, your local or a number of different lists. But in a situation where you don't get that information from the beginning or cannot use it in the configuration, then it will also have the capability and find out if there's something that can be resolved via NENA. So actually, if the list is not configured in the Kamailio config, then the lost module doesn't stop or raise an issue, an error. It would then just try it using NENA, and if it can't resolve it, then it would log an error. With held, we also have kind of different responses. As I mentioned before, we can get the location by reference, or actually we can request the location by reference from the list. And You can also have some location by value being returned, which is the usual way, because then we get a bit of flow and we don't have to, let's say, dereference again. And this can be specified in the post request. And in addition, in the post request, you can also set a specific purpose. So for instance, if someone uses the lost module at the control room side, it would be necessary to dereference location and specify that the location is being used for emergency dispatch. The default setting at the lost module is to use it for emergency routing. The difference between emergency dispatch and emergency routing is quite important, because emergency dispatch means, okay, I want to have a location which is very accurate, and I really don't care about how long it takes to get a response from the LIS. So this may end up in response times up to, let's say, 5 or 6 seconds. If we set emergency routing, then the LIS knows, okay, I have to provide a location, which can be quite rough location information, but I have to do it very fast. And when we did the test last time in March, we had a mobile network operator calling in via voice over LTE, and they also provided the LIS. And we've seen that if you set, let's say, emergency dispatch, or if you do not specify that value, for instance, then it takes quite long to get the location response, which ended up in canceling the emergency call from the mobile network operator side, because it took too long. Yeah, setting the right parameter, which means setting emergency routing, we got immediate response that can be used for routing purposes. So quite important thing, yeah, to know that this can cause some, I wouldn't say cause some issues, because both things serve a certain purpose, but one should not, let's say, mix it up. So emergency dispatch is not being used for routing. For this, there is this certain emergency routing parameter that needs to be set in the post request. The slide shows here an example that can be used in the Kamailio config, for instance, to grab the information from the geolocation header, filter out the URL, and then just dereference it via the function provided by the lost module. So in this case, it's lost health dereference, and you see you can set usually you set the URL as first attribute and the emergency dispatch. Then you can say, okay, I would like to get the civic and the geodetic information back. And then there is the variable that will be set by the lost module, which then contains the bitf, or actually the reference. The other way is location by value. So this means that we explicitly requesting civic or geo location information at the LIS, or this can be something that is already part of the call setup. So if the client knows its location, then it can also provide this, or typically provides the known location via location by value. There's also a possibility to mix these two things, to say, okay, I provide a location by value. This is the location I know when the emergency call is being set up. And then I'll provide, and in addition, I provide a reference that can be used later on to query location information servers just for updates. There's also kind of additional information that's covered by the lost module is that the LIS may provide different location types. This can be expressed by the attribute location type, and you can set this to any. So then it's up to the server to provide some information. You can explicitly ask for geodetic, civic, or location URI, which is location by value. And there's another attribute not shown here, which just forces this to be exact. Yeah. So if you set one of these values and you would like to have it exact, then the LIS would only provide that one. And if it doesn't have it, it would raise an error. So typical setup is exact is not set to true and any, because lost module can work with geodetic and civic information. The other interface towards the ECRF, the emergency core routing function or lost server or service, is the ECRF. So it's a lost protocol server location information and the service URN surface input to a mapping function that returns the URI. So I said this in the beginning. We have the URN, we have the location, and then this being used to start a find service request. Usually this is configured or pre-configured. So the ESRP knows the ECRF, knows also perhaps if there is a specific certificate coming from the ECRF, or let's say an API code or whatever that needs to be used to query or to authenticate, then this is as part of the configuration. The lost module reads the geolocation header and then runs a find service request. And reading the geolocation header means, okay, if it's a reference, then we have the difference first at the list, getting the beta flow, or if it's a part of the zip message, then just passing the beta flow in the message and create a find service request. Yeah, mapping results are then returned to the routing logic, and usually this is then the destination URI being used to forward the request. Yeah, here's an example of some verbose output of the module getting a find service response. So you have these informations that are part of the specifications, or this expires, last update, then the source, who is actually providing that, also the identifier of the source. Then, yeah, this is just German police emergency service. It's using 112. So actually in Austria, if you dial 112, you get to the police. We have also the service URN that's being requested, then the URI, and the information from where we got that. So the URI is actually where we have to route the call to. There's also one thing to know is that the ECRF can also provide the service boundary with a response. So this can be value or reference. If it's a value, then the TCP message can be quite huge. This may cause some issues and overload the receive path or whatever. So it's better to set this to a reference, which is actually default. Yeah, and we do see some different flavors in how one has to deal with a lost hierarchy. So there can be iteration or recursion mode, and I have some further information on the next slide. So in iterative mode, the ECRF returns a redirection response indicating the next server. So in that case, the lost module needs to support redirect as well, and so it takes care of the NENA query and also the loop detection, because it could happen that the next ECRF points to the previous one. So in this case, if the green points to the yellow and vice versa, you would have a loop. And this is also being detected by the lost module. There's also a parameter that can be set in the module. It's called recursion. If it's set to 0, then recursion is not allowed. And in this case, the ECRF shall not recurse. So this would mean it always does the iterative mode. The other way is recursive mode. So that's the easy part for the lost module, because here it just works as lost seeker, but still supports redirect responses, because even if you set this parameter in the request, so recursion would be allowed, and then the ECRF may still do a redirect. Yeah, so it doesn't mean that, okay, if we just want recursion, that we only get this recursive mode, we may get a redirect as well. Yeah, interoperability. I already mentioned that in the February, beginning of March, we had the first joint ETSI Plugtests event, joined together with the NENA IS9 testing. And that was really interesting event in several terms, because we had first time a mobile network operator connecting and being the emergency call originating party in that context, also providing a LIS. So just checking, okay, can we connect to, let's say, a third party LIS from such an ESINet with all the different elements. And we also tested this TLS, MTLS, and we did a lot of use of scenarios in terms of peering. Yeah, so for instance, if you connect to your VoIP service provider in the US, but you provide a location from Europe, for instance, because you're traveling, then you would get connected to the US ESINet, and then thanks to the peering and to the ECRF and lost hierarchy, you would be forwarded to a European PSAP. And that's actually that scenario was being tested in addition to having different credentialing agencies. So from the US, we got certificates. From Europe, we got certificates, and we tried to combine those. So was quite interesting and sometimes quite tough. And what was tested, so just to give you the scope of the standardization, was the US version. So it's the NENA SDA 010.2, also called IS3. And in Europe, we tested the ETSI TS 103479. So it's basically from the main functionality. We have the same, but there's some flavors for the US and some flavors for the European side. And in Europe, we also tested this 103.698, which is kind of lightweight messaging protocol solution. And in fact, very interesting Plugtest event and a lot of lessons learned, and especially TLS, MTLS, that's quite challenging and worked quite well with Kamailio. Last but not least, a few words about projects. We did also some testing in Europe using Kamailio and the Lost module, where we deployed ESINet, this next generation infrastructure in Austria, Denmark, and Italy. And we did a lot of testing moving cross-border and comparing this with traditional emergency calls. So usually if you are at the border and you're still connected to your home mobile network, for instance, but you're already across the border, you will be connected to your home PSAP, but you're actually out of the serving area. And doing this with the next generation infrastructure, we always get connected to the right PSAP. Was quite interesting to also combine different technologies and also enable some policy routing depending on the media content. They are routed to different PSAPs, routed to different call taker solutions. There were 3 companies involved. That was Gridcase, Frequentis, and PET80. And there are a lot of results on the web. If you just Google for EENA and CELESTE project, and there's a nice report. And the other thing I would like to mention, because this is in operation right now and it uses Kamailio and Lost module as ESRP, is this DEC 112, Deaf Emergency Call in Austria. So it's a standards-based solution. So we have an ESRP and an ECRF. The Lost interface is in place here, and also this lightweight messaging protocol. So the solution provides a text chat to emergency services and also some kind of infobot if you introduced with COVID-19. And currently we have the Austrian federal states defined as polygons, and emergency services 112 and 133 the police services, so the Polizeinotruf in Austria, and 122, 140, and 144. So it's fire brigades, mountain rescue, and the ambulance. They get to a specific emergency center in Lower Austria. But I think in a few weeks we will have another federal state in Austria directly connecting. Then we have to change a little bit our routing. So this was a private initiative funded by NETID in 2 years, and then this was also the, let's say, the origin of the Lost module I mentioned at the beginning. Just looking at the time, it's already 4. Let's get to the summary. The Lost module implements the essential features that we know from NG 102.911, and again can be considered as the standards-based feel-good package. So I'm pretty sure that there are other solutions around using Kamailio, but this module just provides a very easy access to that service, because you don't have to deal with all these different interfaces. It's just a simple configuration, and everything actually works in the back if you do not do the tricky stuffs. It has the main interfaces, held and lost, and this has been tested already several times. So there was a number of Plugtests events. So we had already number 4 in Europe, and there were also some NENA industry collaboration events where the module was tested with other solutions. So not just the same ESRP, but different ones, for instance, and also connecting to border control functions and other elements, and for sure also forwarding it codes to PSAPs. It's in continuous operation in Austria since 2019. So we started February the 11th, so the 112 day in Europe with the service, and still working and still growing in terms of subscribers using it, and also the PSAPs joining that service or connecting to that service, and some feature outlook. This is something I learned during the last NENA ICE event, is where perhaps Lost module can also provide some logging information towards the NG 911 logger. This is just event logging, not media logging. So that there's specific interfaces being defined, and that I think is still missing to fully integrate it with NG 911 deployments. Last but not least, I would be very happy about some feedback if someone has the Lost module in use. And that's the end of my presentation. Thanks a lot, and just drop me a line.
Thanks, Wolfgang. Very informative and useful presentation. I saw a bit of a chatting on the side. Maybe Ole or James wants to ask a question, or?
Well, no, not really a question. Note the Kamailio hat, but more a comment. I really appreciate the inclusion of a test button in your DEC 112 system, because a number of times I've got myself into trouble testing emergency calling systems, and there is no clearly defined test setting for emergency calls. So the fact that you put a test button in there is absolutely brilliant. I think we ought to do that with all our emergency calling.
Thanks for that feedback, and just to let you know that the standardization for the next generation emergency calling considers also test facilities. So there is a specific service URN that is specified to be used for testing purposes, that will connect you to the PSAP, but not necessarily to the call taker. So you can check, and if this gets to the PSAP, you may get the feedback that says, okay, you're connected to the PSAP, everything works fine, but that's not an emergency call. But you're right, usually if you have a phone, then you do not have the capabilities. You can try and then just convince the people in the control room that it was just a test.
Yeah, it's difficult. But anyway,
yes.
Thanks. Excellent work, Wolfgang. And I feel that after this, we're going to have to hook up and cook up some really interesting scenarios to do some emergency calling things.
Yeah, sure. Would be nice.
Okay.
Okay, any other questions? If not, I have one quickly. For me, it's not clear with this, standardization, but it seems some countries or some, I don't know, regions, these autonomous regions in different countries, they go on different paths. Is it something agreed at the European Union level already, or it's still like doing the best proof this is the right technology to do it?
I think it's a slow process. Yeah. So I also know a region, a quite huge region you're familiar with, that has its own ideas. But if you look into details, I think everything needs to do this kind of mapping and routing, and at the end, it's the SIP protocol. Yeah. So perhaps the different solutions are just different acronyms and different names that's being used, but it is at the end something quite similar. And I think if it gets to the situation where you have to interoperate cross-border, I didn't mention that, but I had it in one of the slides, then you have to stick to a standard. And I think currently countries are getting more awareness of it, and there's a lot of room also at EENA level. And the next EENA conference in 1 month has a focus on this kind of NG technology, yeah, or NG stuff, and I guess, yeah, as I said, there is a lot of awareness right now that moves into the right direction. But I agree, it's a bit slow, and countries still do not know how to deal with it. That's perhaps also because we do have standards that are quite new. Yeah.
Okay, thanks so much for your presence here and the presentation.